Alright, here we are going to be looking at our dilation and scale factor 4.10 SBW. This is our help video for the SBW. I'm just going to go ahead and get started with the objectives today, where we're going to be drawing a dilation whose center of dilation is not the preimage, dilation whose center is the preimage, determine the scale factor using dilation, and then determine if a dilation is expansion or contraction given the scale factor. So these are the objectives from the previous lesson on Tuesday. Okay, so what we're going to do today is we're going to work on some application problems. I'm going to specifically point out how those application problems can help you on your SBW, and I want to point those out actually at the beginning when I go through the problem context. Okay, I'm going to start with the actual problem first, and then I'll jump over to the SBW and kind of clarify each of the parts and components that we want to think about. So there's essentially there's going to be about 3 slides or so that I'm going to walk you through, and then I'll jump over to the SBW. So we're going to start with the problem itself. Okay, we have some candy here, and of course with Halloween time that's the best time to have candy. But it's better to have even more candy, and we want everyone else to have less, I suppose. Very competitive, I guess. And so we have some potions here that are going to enlarge or contract the candy size, and we have to figure out how we can test those potions to see whether or not they're doing the job that they need to do. So in dilation, remember that dilation is a transformation where the size actually changes, but the shape remains or stays the same, right? So the size is changing, but the shape stays the same. And also remember for scale factor, the scale factor is the ratio of the length of one side on the image, okay? Of course, that is compared to the length of its corresponding side on the pre-image. And this is the notation that we often use to describe that. So we're going to use our potions to enlarge a chocolate bar by a scale factor of 2, and then contract the chocolate bar by a scale factor of 1/2. So they're giving us scale factors in the problem, and what we want to do is compare our new chocolate bars with the original. Our original chocolate bar had an area of 16, so after we test the potions, we want to find the new areas as well. Okay, so this will be the problem that we're going to work on together, and I'm going to refer back to this when I go to the SBW itself. Okay, so let's venture over to the SBW and see if we can compare these 2 bullet points with the bullet points that we're going to see in the SBW. So here's the problem for the SBW itself. In the SBW, we have a Johnson family farm, and they're planning on designing triangular shaped plots in their pumpkin patch for 3 different pumpkin varieties. And the original plot is a triangle with the following corners. You can see them over there on the far right in the orange diagram. And the area of that particular triangle is 8 square units. And what they want to do is they want to create scaled versions of that plot. One of the plots will be expanded, and the other one's going to be contracted. They're going to use the exact same scale factors that we're going to see in the examples above. And so it's going to be centered at the origin as well for the jumbo pumpkins and as well for the mini pumpkins. So here are the questions that we have, or you can think of it as kind of like a summary. We are looking for what the coordinates are for the vertices of the enlarged pumpkin plot by a scale factor of 2, and also we're looking for what are the coordinates, and I'm going to use orange here, good for pumpkins I guess. What are the coordinates for the contracted pumpkin plot with a scale factor of 1/2? So let's keep those questions in mind, and let's think about how we can apply that to our first example with the chocolate bar. If you look at the chocolate bar, we're just working with a different object. It's a chocolate bar, but we're going to be doing essentially the same exact thing with the exact same scale factors. So let's now take an example of this problem and show how I would go about doing that for the first 2 bullet points. If this were an SBW, this is what the first 2 bullet points would look like. So let's go ahead and start by identifying the coordinates that we already are given, right? And we can go ahead and do that by writing them out. So we have, in this case, I'll put parentheses here in blue, we have 2 and 5. Okay, so 2 and 5. We have 6 and 5. And we have 2 and 1. Now I spaced them out like that because what I'm going to do is I'm going to go ahead and in red here, I'm going to multiply this particular x coordinate by the scale factor of 2 alongside this, alongside this, and alongside this, alongside this, and alongside this. Because we're talking about enlargement. We want to enlarge the figure, so we have to multiply the coordinates by the scale factor of 2 to make them bigger. And when we do that, we come up with a new coordinate for our problem set. So in this particular case, I have 4, 10 as one of my new coordinates, 4, 10. Another coordinate I have is 12, 10. And finally, the last transform coordinate is, in this case, 4, 2. So now I have all of the new coordinates of the enlarged figure. That's the vertices of my new figure. That's how I find that. I multiplied the scale factor by each of the x and y values. So how do I find the coordinates of the contracted chocolate bar? So contracted chocolate bar means that you're going to, let's use orange here. Remember, orange went with the second bullet point, green with the first. I'm going to be using a contraction instead. So I'm actually going to do something very, very similar here. I'm going to write the coordinates out like I did before, as you can see. But this time, instead of multiplying by 2, I'm going to actually go ahead and multiply by 1/2. And I'm multiplying everything by 1/2. That's the goal here. So I've got 1/2, 1/2. I'm multiplying all of those coordinates there by 1/2, and that's going to create my new coordinates after the dilation has occurred, because that's what we're doing. We're using dilation here. So here I get 1 and the decimal 2.5. Here I'm going to end up with 3 and the decimal 2.5. And then here I get 1 and then as a decimal 0.5. So my new coordinates are 1, 2.5, 3, 2.5, and 1.5. Okay, so I have all three coordinates for the SBW here for my example, my chocolate bar example, and this represents kind of the first two bullet points of what you would want to do on your particular problem on the SBW, right? You are given the coordinates of your problem, and you are also told what the scale factor is, right? So for the expansion, you have a scale factor of 2. For the contraction, you have a scale factor of 1/2. So you're going to do something very similar to that with this particular problem. So now let's go ahead and target the others, right? So let's look at this one right here. The third one is, what is the area of the enlarged pumpkin plot? And so let's go ahead and compare that now to our chocolate bar example. On the next slide, we're now going to find the area of the enlarged and an area of the contracted. So the area of the enlarged, this would be my third bullet point if that were my SBW problem. And what we want to do with this is we want to recognize that our scale factor, which you can either call T, like in the notes, or you can call K, is going to equal 2. In this case, we're using K because, as you can see, that's used in the formula below. So the scale factor is going to be 2 in this case. Now, in the other case, K is going to be 1/2 when we're using a contraction. We're not doing that here. So in order to find the area, all I have to do is take the scale factor, which is 2, and square it. And then I just need to multiply by the original area. Now, it says here that the area of our figure is 16 square units. So I'm going to multiply 2 squared by 16. So 2 squared is 4, and 4 times 16 is 64. And that would be squared units. That is going to be my area in this case, 64 square units. So now I've shown how I would go about doing my third bullet point in my SBW assignment. Okay, so I went ahead and I found the area by multiplying the scale factor squared by the original area, right? So you might want to think about, okay, where did they give me the original area in my SBW problem, and do I know what my scale factor for enlargement is going to be? Well, I highlighted the enlargement scale the scale factor for enlargement in green, and also they tell you the original area. Pay attention, they tell you that the area of the original plot is right there, so they tell you what to use in the problem. And so the final problem here, and I guess I'll go ahead and use a different color, I guess we'll just use this color, is we want to find the area of the contracted pumpkin plot. So if I go back to my problem and examining it, I have my contracted pumpkin plot, and I want to find the area of that new figure now, right? So I'm going to go ahead and compute that. So here we have the area is going to equal 1/2 squared. That's the scale factor I'm supposed to use right there. And I'm going to multiply that by the original area of the chocolate bar. Now the chocolate bar's original area is 16 square units. So 1/2 squared is 1/4 multiplied by 16. And 1/4 and 16 is 16 over 4. 16 over 4 is equal to 4. So we have 4 square units now as opposed to 16. So the area is 4 square units. And that would actually, if I looked at this slide and this slide here, that would represent exactly what I need to do for the best amount of success possible on the SBW for this particular assignment. Okay? So utilizing that information that you have there, reference that particular slide to help you better understand how to go about writing out the coordinates of the vertices for the enlarged pumpkin plot, the coordinates of the vertices for the contracted pumpkin plot, the area of the expanded plot, and the area of the contracted plot. If you have any other questions related to this, don't hesitate to reach out to your teacher for SBW Help or any help on any of the assignments related to this particular topic. That's going to be our video as an example of how to best set up your response to the SBW for 4.10.